Okay, lesson 55. We are going to solve advanced abstract equations, which sounds very high level, doesn't it? And word problems and quadratic equations, so much. So we're gonna have to start flying here. You ready? This is just like what we were just doing, solving for a variable when there's no numbers involved. So here we go. With no further ado, it says find P, and we have M plus S over P plus,
where are we?
oh, page 239.
Okay.
A over X equals T. These are the practice problems. So what do we want to do? What does everybody hate in math?
Cross multiply.
No, we love that. But that is the answer everybody wants to say. You tricked me. Okay, so and nobody likes fractions in math, right? And I'm okay with that. I have no problems with that. Let's get rid of them, in fact. So how would we get rid of the denominators? It's counterintuitive. We want to get rid of them, we need more of them. So we're going to actually multiply this entire problem by the least common denominator, which is px. So we'll multiply, I like just to do each one, just by px. Because whatever you do, remember math is like finally a world that's fair. And it's not like at home where you say, but Mom, Zach got this, and she says, too bad, okay? In math world, if you say, this one got this, M plus S over P got a PX, well then everybody gets a PX. It's like Oprah. You get a car.
Socialism.
You get a car.
It's
You get a car.
socialism.
Socialism. Not exactly. Okay, so this, what happens here when we multiply PX by this? The P's are gone, yay. And then we can distribute the X, so we get XM plus XS. Happens here, the X's divide out, right? And we get PA. And then here, we just get PXT. And we always have to keep going back. What was our point? What are we trying to find here?
We're trying to find P.
That's right. So what does that mean? If we want to solve for P, we want to get all of the P's on one side. So an easy way to do that, we've got one here and one here, and then all this stuff. So we can move this PA to the other side. And whenever we move something to the other side, we have to change the sign. So we get XM, still here, plus XS equals, let's just say PXT minus PA. We moved it to the other side and it became a negative. So now we have all the P's on one side, but they're in two different terms. So we can factor out the P, and that would leave us, again, this side's exactly the same, and we just, Gavin, always want to show as many steps as possible, right? I know that's your motto. So we rewrite this, because nothing changed there, and we factor out a P, and if we factor out a P, we're left with XT minus, oops, wait, that's a T, XT minus A. We're getting there, we're almost there, P is almost by itself. What is keeping P from being by itself? This mess here, and this, so how do we get this over there?
We do the opposite operation.
Thank you, music to my ears, which is?
Division.
Yes, so we just divide by that whole thing, and then do the same thing over here, xt minus a. So find p, what does p equal?
That giant fraction thing.
P equals xm plus xs over xt minus a. Now the trick is to make your t and your plus sign look different. If you can do that, you can conquer the world. Isn't that what they say? Isn't that how the saying goes?
I believe so.
Thank you. All right, then we have, I should probably be checking to see if these are right. I mean, I was wrong once, remember? When I thought I was wrong and I was actually right. But you never know, it could happen. Let's see. Okay, so they go one step further. Sometimes they do with these answers, sometimes they don't. And they do up here what we did here. So we have the xt minus a, and they just factor out the x. They go that next step, kind of preparing you in case, you know, whatever. All right, next step, next problem. Find 3 consecutive integers such that the product of the first and the third is 5 greater than 5 times the second. That sounds fun, right? So as always, we want to first define our terms. Isn't that part of everything, part of life, defining your terms?
Yes.
Yes, absolutely. So 3 consecutive integers, we're going to write them over here. Our first one is n, then we have n plus 1, then we have n plus what?
N plus, right.
Plus 2. So, all right, now we're going to break it up. It says find 3 consecutive integers such that the product of the first and the third. So, product of the first, product means,
Multiplication.
right, n times first and third, n plus 2 is 5 greater than 5 times the second. So is 5 greater than 5 times the second. Now what's tricky is when I say 5 greater than, it's easier just to say 5 plus. But if I were to say 5 less than, it would have to be over here. Like this would be 5 times this minus 5. Does that make sense?
Mm-hmm.
Okay, so now we have to solve this. So what do?
Distribute.
Distribute, and we get n times n is
N squared.
plus 2n equals 5 plus 5n plus 5. Combine like terms, right? This becomes 10. Anything else we can combine? No, you notice we have squared. So that's going to be n and n. So that's going to be fun. So let's get everything onto one side. So we get n squared plus 2n. Oh, we need to bring this 5n over. And what happens when we do that?
Becomes negative
Right.
at the end.
Minus, okay, well, you just want to jump ahead, sure. And then if we bring the 10 over, we have a minus 10. And what's left over here? Zilch. Okay, now let me catch up to you. N squared minus 3n minus 10. Then what? Now we go back to the days of factoring. Yay! Factoring a trinomial, what could be more fun on a Thursday chilly morning?
Coffee.
Coffee? Yes, I do not, you're not wrong. I don't disagree with you. Coffee and factoring trinomials on a nice chilly day. It's like the perfect. Okay, what goes here? And thank you. And this means our signs are going to be different. So we're looking for factors of 10 that when you combine them, give you a -3. So the signs are going to be different. What are my factors of 10?
5 and 2.
Yeah, 5 and 2. So which one's negative?
5.
Right, because that ends up being a. And let's check it. So we get 2n and -5n, and that gives us -3n when you combine them. So boom, done. Now we have these two factors, so we have to set each factor equal to 0. So we have n minus 5 equals 0, and n plus 2 equals 0, n equals 5, n equals what? No, I'm just doing it for you. N equals -2, right? Are we done?
It's 3 integers we have to find, right?
Yes. So, we're not done. We now need to plug these back into our original situation here. So we would get n is 5 plus 1, 6 plus 2, 7. So those are 3 consecutive integers, and we can check them such that the product of the first and the second is equal to the, oh wait, hold on a second. I'm looking at the wrong one. Product of the first and the third is 5 greater than 5 times the second. So is 35 5 greater than 5 times 6? Yes, okay, great. And then the other one is -2, so that would give us -2, -2 plus 1, -1, -2 plus 2, 0. So does that one work? Is the product of the first and the third 0? 5 greater than 5 times the second? Yes. You'll have to trust me on that. Or work it out later. All right. Great.